So today we'll discuss about another machine learning project, diabetic detection in men using machine learning algorithm, and we use logistic regression algorithm. So here, first thing, logistic regression is a supervised machine learning algorithm. There we use binary classification, which takes the input data from the data set and produces output 0 or 1. So if the output is 1, means in this case the person has diabetics, or we detected diabetics. Okay, if the output is 0, means the person has no diabetics symptoms or something. Okay, so we are going to first discuss about the data set. This is the data set which I already downloaded. Glucose level, blood pressure level, body mass index of that particular person, age, insulin level, pulse rate, family history, whether anyone in the family has diabetics or not, that history, and the outcome. Okay, so based on 1, 2, 3, 4, 5, 6, 7, based on these 7 features, the outcome will be 1 or 0. Outcome 1 means the person has diabetics, so the chances of diabetes is more. 0 means there is no worry. Okay, there will be no diabetics, or we didn't predict anything for that particular person's features. Okay, these are the first features. 7 columns are features. Eighth one is target or outcome or output. Okay, so this one I'm going to run the program first. As usual, we want to upload the data set. So I have already uploaded the data set. Where I have put is, I put in my PC. So here, semester 2, this one, machine learning. I put the data set. Okay, mail underscore diabetes underscore data. This one I already uploaded here. I took the which one path, and I put the path here. Okay, so before that I will run the which one packages. What are the packages we need? Pandas for processing that array data, then train underscore test underscore split to divide the data into training data, testing data, test data. We need this package from sklearn model selection. Then we have logistic regression. So to call this which one machine learning algorithm, that logistic regression model, right? We need to use from sklearn linear model. Then we use classification report, confusion matrix, accuracy score. All these things we'll discuss. These are being imported, okay, from sklearn.metrics. Import job just for downloading the model. Okay. After that, I want to read the data from the data set. So I already put the path of the data set. Now for reading, I want to use the object of pandas pd dot read underscore csv, because it's an Excel file, right? CSV of the path of the data set. I read. Now, if you want to print this data set, just I will print for you, print of data. Let's see what happens. Okay. Okay. Not data, df. No, sorry, df. Now see, it will print 500 rows, 8 column, 1, 2, 3, 4, 5, 6, 7, 8. Okay. In that last one is outcome or output or target. Others are features. Okay. Now we want to, if you want to print the first 5 rows or last 5 rows, you can try that. Okay. For that we have to just put here head. Let's try this one. Okay. This one. Okay. First five only. Tail means the last 5 rows. Okay, last 5 rows. Now I want to drop the outcome field, and I want to make features in x, and outcome will be in y. For that, the object name df dot drop, what column, which column you want to drop, put in the double quotes. Okay, outcome column, axis equal to 1. So you have to drop one column means axis 1, column you have to drop a row means axis 0. So I drop that, and without that outcome we get x. Y has only outcome. You want to print that X and Y, just put here print bracket X, then print bracket Y. Try this. X means only glucose, blood pressure, BMI, age, insulin pulse rate, family history. Okay. Y means only the outcome. See. After that, I want to divide the data into training data, testing data. Okay. So for that, the same X underscore train, any training data set about features. X underscore test, testing data set about features. Any these things, features. Next is Y underscore train, training data set with which contains what? The outcome. Y underscore test, testing data set which contain outcome. Now, how do you get these things? We divide by using the function train underscore test underscore split x comma y, then test size point 2 and random state. This one, 20% of the total data, 499, right? That 20% will be used for testing. Remaining 80% rows for training. And after that, we want to call the logistic regression model. So let me run this one. Okay. Now call the model and max iteration. So how many times you repeat this until you get the output, right? So max iteration 1000. Then the model you have chosen. Now we have to train the model. So model dot fit of x train y train. Now we are going to train the model. X train means the training data set which contains only features. Y train means the training data set which contains only the outcomes. So we have to train that model by using fit function and give this inputs. Done. Now we are going to predict the x underscore test. Okay, so I give the input as x underscore test. That means testing data set which contain features. Model dot predict of x underscore test means based on the value of features available in testing data set, the we can get the y pred means the which one predicted outcome. Okay, so given the x underscore test, that means the testing data set which contain features, we use model dot predict function and we get the outcome prediction in y underscore pred. Now you print that accuracy of this model using accuracy underscore score, and we mentioned the y underscore test, y underscore pred. Y underscore pred means the one which we got when we predicted the output, or predicted the output by giving x underscore test value. And y underscore test means already we have y underscore test where we have testing data set of the total outcomes. Okay, full outcome. We are comparing, we are using these two variable and we get the accuracy score like 93%. What is confusion metrics? See, there's a new term for us. It's a performance evaluation tool in machine learning. They represent accuracy of the model. So how accurate is the model? For that we have a matrix and we have four things: TP, true positive; TN, true negative; false positive, FP; false negative, FN. What is true positive? The model correctly predicted someone had diabetics. Okay, so here 52 space 2. This means model predicted that 52 people have diabetes. And this one is true negative. This one, 41% or 41 people don't have diabetics. False positive. What is false positive? The persons who have diabetics, but two persons, if the system found that two persons don't have diabetics, actually they have. See here, true negative. The model predicted someone did not have diabetes. Okay, sorry, false positive, right? Model incorrectly predicted that someone had diabetics when they did not. Actually, they did not have diabetics, but the system predicted. That is false positive. What about false negative? The model incorrectly predicted that someone did not have diabetics when they actually did. Okay, so this 5 indicates that the system, the model told that or given the output that someone don't have diabetics, but actually they have diabetics. This is confusion matrix. Okay, so this will represent or tell the accuracy of the model. So by using these four terms, we can check the accuracy of that model. That's what confusion matrix. Then classification report that we already discussed in the previous video. What about precision, recall, FN score support? You can check that. After this one, what I'm going to do, I'm going to give a sample value. Okay, 145, 85, 31.2, 52, 110, 78, and 1. What are these things? Blood glucose, blood pressure, BMI, age, insulin, pulse rate, and family history. Giving this input, raw input. Okay, I am going to predict the outputs or the outcome. So model dot predict of sample of 0, the full row. Okay, now what happened? I am going to use a printing statement which is look like a ternary operator. Okay, so printf print prediction. So the term prediction will come. Then diabetic if prediction equal to 1. Okay, so what is the value you get in the prediction function? As I told you, logistic regression always give two values, 0 or 1. So if it gives 1, that means print diabetics. Else, if it is 0, print not diabetic. So here the prediction is diabetic, that because that value we get in prediction is 1, so it is diabetic. He is diabetic. Okay. If it is 0, then it will say prediction non-diabetic, not diabetic. Okay. Now to download the model, we used pickle library in the previous activities, right? Now we are not using pickle, we use joblib.dump model. Give a model. This is the model name you want to give. Then just printing that model saved. So I'm going to run this program up to where? Okay, here done, done. After that, done. Then print accuracy 93%. Then prediction equal to model dot predict of sample 0, the full row. Now it is diabetic. Okay. Now I'm going to give a new which one model name, model 3. It will appear on the left side in few seconds. And once it is done, see it's coming. Now what I can download this model. Okay, download the model and save in a local file. Then I can use it in a Raspberry Pi program where I will give the actual values of the that glucose level, blood pressure level, everything via sensors. Then we can upload the data to cloud. So whenever any alert, whenever any which one notification, no, whenever any emergency means the notification will come in the mobile phone. All those things we can do using TeamSpeak and video with the help of Raspberry Pi. This is one. How do we predict the which one diabetics in men using machine learning algorithm with the help of logistic regression? Hope you understand.